Now we're on to the second category, evaluate logarithms level 2. So let's go there. We're going to evaluate the log, or we're going to find the value of log base 9 of the fifth root of 81. So let's rewrite, let's rewrite this as an exponential. So turn on my annotations. So this is equal to x. We're going to find out what x is. So 9 to the power of x equals the fifth root of 81. Okay, so at first glance, this one looks a little bit more complicated than the other one. However, all we have to do is manipulate this little piece until it turns into 9 to the power of something. But before we can do that, remember that the fifth root is actually an exponent of 1/5. So I'm going to rewrite this. So rewriting this, 9 to the power of x is equal to 81 to the power of 1/5. And remember that 1/5 is just rewriting the fifth root. So it was 81 to the power of 1, so that's why there's a 1 on the numerator of our exponent. And then on the bottom of our exponent is a 5, so 1 over 5. And that 5 is because it is a fifth root. So 81 to the power of 1/5. So we're getting closer. I'm just going to rewrite this over here. I haven't changed it. 9 to the power of x is equal to 81 to the power of 1/5. Okay, so let's rewrite 81 as 9 to the power of something. So, haven't changed that part. 81 is 9 squared. Okay, now before I go on, are there any questions about anything I've done so far? Okay, so let me keep writing 9 to the power of x. That hasn't changed yet. We just want to know what x is. And then over here, we have 9 squared to the power of 1/5. And all we have to do with these exponents, the 2 and the 1/5, we just have to multiply them. So 9 to the power of 2, 2 is technically 2 over 1, times 1/5. So 9 to the power of 2 times 1/5. Those 2 and the 1/5, you just multiply it. I just wrote 2 as a 2 over 1 just because it's easier to multiply two fractions. Okay, and so to multiply those fractions, you just multiply straight across the top. 2 times 1 is 2, and across the bottom, 1 times 5 is 5. So now we have 9 to the power of x is equal to 9 to the power of 2/5. Therefore, x is equal to 2/5. And that would be your final answer. You don't have to write the x, you just write 2/5 into the answer box. Are there any questions? So I'm going to type in 2/5. Okay, let's do another one. So many buttons to click. Okay, clear all drawings. What is the value of log 1? Okay, so this one looks weird. You're like, where's the base, right? Usually there's a tiny little number here. So where did that go? So this is your most common logarithm. It's just the most basic logarithm. It's a log base 10. So if you don't see a base there, it is a log base 10. So I'm going to rewrite that. Log base 10 of 1 equals x. So we're going to find out what x is, and then let's rewrite this as an exponential. 10 to the power of x equals 1. So this is what we want to figure out. X has to be what before 10 to the power of x equals 1. So if you don't know this off the top of your head, that's okay. I'm just going to remind you now that anything to the power of 0 will equal 1. So then we want 10 to the power of 0. And if you don't believe me, you can try it on your calculator as well. But I also just want to remind you, anything to the power of 0 equals 1. Even like 99 to the power of 0, that's still going to be 1. Or like 300 to the power of 0 is going to be 1. Like anything to the power of 0 is going to be 1. So here it says log 1. This is going to be equal to 0. So log 1 equals 0. Are there any questions on this one? And so let me enter in the 0 because our x is equal to 0. And then let's do another problem. And let me turn on annotations and clear all of that. Okay. What is the value of log base 7 of 1/7? So let's call this x, and we're going to find out what x is. So 7 to the power of x equals 1/7. Okay, so here we have a fraction, and I know fractions are a little bit scary for some people, but that's okay. You just got to get used to them because fractions are like any other number. Even like this number 7 is a fraction. It's just 7 over 1. You just don't see it as a fraction. So fractions, just treat them like any other number. So they're not as scary as you think they are. So 7 to the power of x is equal to 1/7. And then anytime you see a fraction like 1 over 7, it's actually just a flipped 7 over 1, right? Like the two things that I just circled are just reciprocals of each other. They're just flipped versions of each other. So what that means is that the x, the exponent, is going to be a negative number. So 7 to the power of -1 is actually 1 over 7. And that -1 as the exponent just takes the original fraction, the 7 over 1, and it just flips it. So I can give you, well, actually, let me just first write this out. So then that means our x is equal to -1. So log base 7 of 1/7 is equal to -1. So that -1 as your exponent just flips your fraction upside down. So the answer is -1. I'll also give you a couple more examples because I know it's been a while, so maybe you don't remember, but hopefully after a few more examples, you will remember. So like for example, let's say 2/3 to the power of -1, this would be 3/2. Like all the -1 as an exponent does is it flips it around. And then let's say you have 2/3 to the power of -2. This would just be 3 squared over 2 squared. So it literally just flips it and then it squares the top and bottom. So hopefully that kind of jogs your memory a little bit about negative exponents and how it flips the fraction, stuff like that. Are there any questions now? I will pause the recording to give you guys a chance. And let me exit the annotations and then type -1. I know it's kind of covered with my annotations, but it is what it is when you're doing it this way. Okay, so that was our last example of Evaluate Logarithms Level 2, because that was 3 examples. So let me stop recording for this one and we'll go to the next video.